In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here, yet again, looking at this Regulator PCB board which failed. An astute viewer in the comments of the last video I did on this, which I'll link the video in the description here, Ferrum Ignis, I think that's how you pronounce your name, pointed out something very, very vital and what the actual problem with this PCB is. Now if we look at the transistors here along the back, you'll notice on my silk screen I've got a little E, which is to mark where the emitter is. Well, that's not where the emitter is on a BD139 or 140. The emitter is actually on the left pin, pin 1, and the base is on the right pin, pin 3. In other words, these transistors are in backwards. So technically speaking, we're pulling our output voltages off of the base of these transistors, which is obviously not going to work, and how this thing even works at all is well beyond me. Now, the fix for this is pretty easy. We can either turn these transistors around 180 degrees and maybe mount, using these heat sinks, the metal tab side to the inside edge of this heatsink instead, or just simply change the transistor with the correct pinout. Enter the TIP 41C and the TIP 42C. That's the 42 and that's the 41. Now their pinout is base, collector, emitter in that direction. So these will work in place of the BD139 and 140 respectively. Plus these are actually power transistors and they can deliver up to 5 amps of current. Not that this circuit will be delivering 5 amps of current. The only difference between these transistors and these is the HFE is around about 75 for the TIPs, whereas the HFE is up to about 200 on these BD139 140s. But that's what I'm going to do, is I'm actually just going to change the transistors. And I can verify the pinout. That's the, should be the base. This is the NPN. That's the collector. And that's the emitter. Same as this. That's the base. If I can get it on there. Collector. Emitter. Perfect. All I'll do is I'll take these transistors out. I might unplug that, it's in the way. Take these transistors back out, and for now I'll just put the TIP 41C in for the NPN and test just this side. We should have a completely different result. So this is not going to be terribly easy, but because it is double-sided, so I'm just going to have to try and do that. Right, transistor is out. Now I can clean up the holes with some solder wick when I can find what I've done with that. Solder sucker works just as well. Perfect. Excuse me. What do I want on that? And I want a Q-tip. Give the circuit board a bit of a clean to get the flux off. Alright, and as these have been soldered to a few times, I just want to clean the legs off. There we go, it's clean now. That should pass through the holes of the PCB, so I can check that. Ooh, it's still slightly hot. Yep, passes through. Just perfect. Okay, and this is perfectly fine. I can reuse this transistor for something else. There's nothing wrong with it. So I'll just put that to the side in my junk bin. Just wipe up the old compound. And I'm going to apply some new compound. I mean, you guys don't really need to see me trying to do a nut up. But someone might find this interesting. And I cannot for the life of me get that bloody nut to do what I want it to do. Could have something to do with the fact that I'm so hungover this morning. Ah, for f***'s sake. Right, that's starting to really piss me off now. Right, got the nut on. I just need to pass the transistor through the holes, and then I can do the screw up. If I can get the transistor to go in. There we go. It probably won't go all the way down because there's a knee on the transistor, which will prevent it from going all the way down. So I'll just take that lead off. And I will solder him in. I'll start with one leg and make sure that it's straight. I've got compound everywhere. Yep, it's reasonably straight. Okay, let's solder these legs in. Okay, I will trim them off later when I'm done testing. So, I need to tighten this heatsink down. Like that. And I might use a Q-tip and some circuit board cleaner to deal with all that excess bloody compound. I really need to get myself like a tub of isopropyl alcohol so I can, you know, clean things off properly. Okay. So it doesn't really matter if there's compound everywhere, but that heat sink is not straight because it doesn't actually go down to the board now because it's slightly shorter. I mean, I don't really need to be so anal about it, but it's more aesthetically pleasing if things look straight. Right, that looks a bit better. It's not perfectly straight, but it'll do. So let me set this up to test. I'll just test it on the positive going side with the positive voltage rather than, you know, putting bipolar on there. Alright, the little circuit's ready to test. I've got the positive supply lead connected to the positive of this capacitor with some jumper leads sticking out the side of the PCB. Just makes it easier than trying to get it into the connector. Now, my multimeter is measuring across the positive output and ground. The ground of the meter is connected to the ground input because I couldn't get a clip lead on that. Anyway, my power supply is set to 19.6 volts DC. Multimeter is on. And we got 16.2 out, so it is probably a little high, but we should be able to load it now and that voltage would not be affected that much. Got a 330 ohm 5 watt resistor there. That's going across my output. Well, it will be in a second. So I'll just connect the load resistor to the positive probe of the multimeter, and there we go. Drops down to more like 15.9, but you're only losing about 200 odd millivolt, which is perfectly fine. If anything, it's actually come up a little bit. So I'll disconnect the load, comes back up, goes back down. Slightly warm. That's still cold. So what's the current draw? About 48 mA. Okay. So I might change my load resistor to 27 ohms. So that's 16 divided by 27. Gives it over half an amp of current draw. So let's try that as a load stress test. So disconnect this one, which is slightly warm now. And I will connect this one. Ooh, it fell right off to about 10 volts, but that is kind of expected because my input voltage has also dropped down to about 17 volts, and it's saying that we've got, you know, 400 odd milliamps of current draw there. Okay, so what I'll do is I'll switch that off for now. I will put both supplies in series with each other so we've got a higher voltage. Okay, second supply is wired in series. There we go, I've got more like 16.9 now. So I'll just reapply the load. Now if that's connected, which it should be, the voltage didn't drop off much. But it says that we've got no current draw. That's because the load's not actually connected. Duh. Let's try connecting the load. And the voltage doesn't drop down that much. Only by about 500 millivolts. Which is, oh, that resistor is getting red hot. So that's good. That heatsink's getting red hot though. Okay, is the output voltage going to vary with input voltage? So I'll just vary input voltage down a bit. It's starting to drop off. Increase it. Yeah, now I'm at the maximum of my supply. The voltage will change with varying of input voltage, which makes this little circuit not very reliable. However, I've fixed the problem. So yeah, it was just the transistor was backwards. That's still retaining quite a bit of heat. So I'm not going to put the other transistors on because, well, it's going to work, yes, but I'm not happy with the varying of output voltage. So as a regulator, it's not perfect. So I'm going to redesign this board with some linear regulators instead, like LM317, 337T respectively, and that'll be in an upcoming video. So yeah, tell me your thoughts down below. If you like this video, please remember to rate, comment and subscribe if you haven't done so already. Anyway, I'm going to leave this one here. This is Yastro30 saying, see ya, have a great day. Oh, and also thank you to Ferrum Ignis for pointing out my obvious error. Thanks mate, that was really helpful.